For our key activity, we had 2 research questions. The first one was, what detergent is most efficient to remove mustard stains from a piece of clothing? And the second one, which is, what detergent is most effective to remove ketchup stains from white cotton clothing?
Well, soap is a sodium salt or potassium salt of long-chain fatty acids having cleansing action in water. Detergents are amphipathic molecules that contain polar or charged hydrophilic groups at the end of long lipophilic hydrocarbon groups. By the other hand, soaps are made from natural ingredients such as plant oils like coconut, vegetable, palm, pine, or acids derived from animal fat. In the test 1, we looked that if Tide is used to remove a mustard stain from a white shirt, it will be most effective compared to the other 2 cleaning detergents because we see it commonly used for laundry in households and it's sold practically everywhere. In the test number 2, we think about it and we got that if we use detergent to remove ketchup stains from 2 different shirts of the best soap will be Roma because it appears to have a stronger effect compared to the other detergents and is commonly found in homes.
Now the experimental procedure, which I'll be listing the equipment and materials we were going to use and basically how it was supposed to be carried out. We needed 2 white t-shirts, 25 milliliters of Salvo, 25 milliliters of Tide, 8 grams of Roma, 7 containers, a beaker for measuring, 1 microfiber, 900 milliliters of warm water, 60 milliliters of ketchup, 60 milliliters of mustard, 3 pieces of synthetic fabric, and 2 sets of gloves. In the experimental procedure, first we must take a container and your mustard, then begin to measure out each detergent. We pour all the ingredients into different containers. We take our white shirt, pour 20 milliliters of mustard, then use 20 milliliters of water, scrub for 1 minute using microfiber, and then finally use 80 milliliters of water to rinse. And basically it's the same thing with the other t-shirt and with ketchup and with the other 3 cloths. It's the same procedure, we just repeat it another couple times, but basically it's the same thing with different materials.
Now, regarding safety and environmental conditions, as in residual disposal or treatment, one example of this research was that with Salvo, it has to be disposed in a container such as hazardous waste, this meaning that it cannot go to the drain. So therefore, a proper disposal of these materials has to be made. A similar case is the one with Tide, which is actually illegal to dispose it in this way. Yet Roma is not another exception, where it has to be catalogued as a special hazardous waste, meaning that all of these procedures will protect the environment from this hazardous waste and its conditions. This is why it's a rule to follow for safety and environmental conditions.
While doing the experiment and after doing the experiment, we basically concluded that the results that we can see now on screen were the ones that we obtained. Basically, what we thought the best soap was Roma because it took out the stains better from both mustard and ketchup in all of the white t-shirts and in the cloths. Roma was the one that took them better, and even though you can still see a little bit of the stains, with Roma you can't see them as much as with the other detergents like Tide or Salvo. So yeah, that is our results that are now displayed on screen. And like we said on our last key activity delivery, basically what we did, like a little summary, was we stained the shirts and the cloths, and then we just put a little bit of soap in them with different kinds of soap, same amounts. Everything was the same amount, same same mustard, same ketchup, but well, the difference was it was performed on different cloths. And yes, so the conclusion is that Roma was the best one. Those are the results.
Hi, so to answer question number 6, analysis and discussion, explain the trends in your graphs. How are the independent and dependent variables related? We can say that in the first set of variables, the independent variables are the type of detergent and the presence of a mustard stain. The dependent variables are the amount of detergent required and the amount of times it takes to scrub it on the clothing. Based on this information, we can infer that the independent variables, type of detergent and mustard stain, are likely affecting the dependent variables, amount of detergent and scrubbing time. For example, different types of detergents may have varying cleaning efficiencies and compared to other types of stains. Type of fabric and type of t-shirt may also influence the amount of detergent and scrubbing time required. Although the specific relationship is not clear without further details. In the second set of variables, the independent variables include the type of detergent, type of fabric, presence of a ketchup stain, and the type of t-shirt. The dependent variables are the amount of detergent needed and the amount of time they scrub the t-shirt. Now, we can infer that the independent variables, type of detergent, type of fabric, presence of ketchup stain, and type of t-shirt are likely influencing the dependent variables, that are amount of detergent and scrubbing time. Different detergents may have varying cleaning efficiencies, and the type of fabric and type of t-shirt may also impact the cleaning process. The presence of a ketchup stain could affect the amount of detergent and scrubbing time required, as different stains may respond differently to cleaning methods. So this was the analysis and of the results that we got from the two tests and how the independent and dependent variables are related. Thank you so much.
Now, after the experiments, we identified some errors during the experiment, and the main ones were probably the method we used to make the experiments. For example, the first experiment, we really didn't know, we didn't really plan it that well on how we were supposed to start the experiment. So we just went along with whatever we thought was best. But as we progressed, it obviously got better because we knew what we were doing and what would work best and would work better. For example, like the stains, we got more even stains on each cloth because the first one was a little bit wonky. The first stains were a little bit asymmetrical. They weren't really like the same size. But at the end, in the cloths, in the yellow cloths, the stains looked better. They were like, they even had this like the same amount of ketchup. So that was the main error that we identified.
After doing the experimental procedure, we could say that our hypothesis was partially correct, since the guess for test 1 was that Tide would remove a mustard stain from a shirt best, and for test 2 we mentioned that Roma would remove ketchup stains from a shirt with most efficiency. The reason for our guesses was that firstly, Tide is a very well-known brand found in practically any market all over the world, and it is specifically used as a stain remover for clothing. Tide, no date. And Roma is known to be a multifunctioning, economic, powdered detergent that removes grease and is also used for bathrooms and simple home cleaning. Roma, no date. With this being said, Roma was the best after carrying out both experiments, being mustard and ketchup stains, as mentioned in our previous reports, which potentially tells us that sometimes the most popular detergent brands are not always the best. In this case, Tide.
Okay, so as for the experimental improvements, we decided to analyze all of the procedure and choose whether some things could be changed, optimized, or modified in a way for it to be more efficient and to reach our goals more easily. And after understanding the results, research has had to be made on how we could optimize these procedures. And after all this analysis, the team concluded that a better practice in measurements had to be made. This because some variables have to remain constant during the experiment for it to have a better outcome. In this case, we are talking about the amount of product, since by keeping the same amount of product in each experiment, with obviously different types of products but same quantity, we could evaluate more easily the efficiency that they have, because perhaps product A has a really good efficiency, but product B has that same efficiency with twice the amount of product A. Would be more efficient since it will need less product than product B. This is why it's really important. Another thing to take into consideration is the amount of water that's going to be exerted in each experiment. This is because it could be another factor that would alter the results, so it would remain constant as well. Finally, another thing to take into consideration is that when disposed of time, a mock-up experiment could be made. This meaning that it's a really small practice where the people who are gonna make the experiment oversee the details and make sure that they have everything in order, planned, and in control.